Well, I say to you that PowerFactory requires that you use data that is presented in real units. What does mean real units? Well, in the case of impedance, the impedance must be presented in ohms. To be honest, if you are using transmission lines, the unit that you need to use is ohms per kilometers, okay? That is the unit representation that we use for transmission lines inside DIgSILENT PowerFactory. Okay, now I believe my students can see one of the challenges. One of the challenges is that the data that is presented, the data that is given in these tables, those tables present here impedance and admittance using per unit system, and inside the software I need to use is per unit values. Okay, ohms values. Well, my students, they are quite good in power system analysis, and all of them must remember that if we have data in per unit, we can convert the data from per unit into real variables using what we call the bases. Okay, this is just a very short explanation, but you must remember, if we have a variable, any variable, and this variable is expressed in per unit system, is because we are dividing the real variable in real units for something that we can call the base. And the interesting thing is that the base must be represented using real units. For instance, in power system analysis, the impedance in per unit is equal to the impedance in ohms divided by the impedance base. But the interesting thing here is that the base must be expressed in real units, ohms. Here, the data provided by the test system is in per unit, and we need to calculate the impedance in ohms. For that reason, it's very simple. Impedance in ohms is equal to the impedance in per unit multiplied by the base impedance, and again this one in ohms. Very simple. But now the question is, how do you define the impedance base? Well, the impedance base, you must remember from your classes, is extremely simple. Is the base, voltage base, square value divided by, regarding units, you must remember the impedance base in ohms. If you are using voltages expressed in kilovolts, you can use here in the denominator the base divided an NVA. And that's all. Okay? What I'm trying to say, my dear students, is PowerFactory use real units. PowerFactory use real units. And PowerFactory require that you translate the units that you are using, translate the per unit values into real values. Okay? And this is the data that is coming from the table 4.1, and this is the data that we need to use inside the DIgSILENT PowerFactory. Okay? Good. Good. Simple. Extremely simple. Okay. Okay. we know that the data that is provided in per unit values is expressed in 100 MVA and 230. What is the next step? Okay, we need to calculate what is the impedance base, and in this case we use 230 kV and we use 100 MVA, but you must remember this impedance base is at 230 kV. The impedance base is basically 529 ohms. Okay? Then we have here, we need the admittance, and we calculate the admittance base using very simple properties. The admittance is equal 1 divided by the impedance, and we get here the admittance. Students must remember again, for the admittance we use the unit that is called mho, and mho is equivalent to ohms but spelled backwards, or we can use microsiemens also as unit. Okay, well, if we know the impedance at 230 and we know what is also the admittance at 230 kV, the next step is, okay, let's convert the data from the table into values that I can use inside PowerFactory. And here in table 4.3, you can see the calculations that we run for our transmission system. For instance, here we have the transmission line between bus bar 4 and bus bar 5. And the resistance, remember the resistance is the real component of the impedance, is 0.01 per unit. But in this case, the impedance base, we already know that is 529 ohms, 529 ohms, using the equation 4.4, multiplying the resistance in per unit by the impedance base, we got here 5.29 ohms. It's something extremely simple. Anyone can use an Excel file, for instance, and they can reproduce all those results. Okay. Some of you are asking, okay, what's about the line charging? We use the name line charging for the letter B in the transmission lines. B is the capacitive susceptance, and this is the reactive component of the admittance. Okay, for that reason the calculation is again extremely simple. We multiply the admittance base multiplied by the line charging in per unit system, and we got here the value. Okay, it's very, very simple to do. Okay, in this case the system is only a single voltage level at the transmission line, and the single voltage level is 230. Okay, however, I am totally confident my students, they can be able to solve more complex problems. Okay, at this moment I will open again questions regarding to the per unit calculations. Any question about the per unit calculations? Any question about per unit calculation, please? Okay, it's look like everything is fine with the per unit calculations, okay? And I am extremely happy with that because that is very, very important, okay? Okay, let's do the following. Next step is we have some problems again with the per unit value at the transformers, okay? What is the situation? Okay, let me go back to the visualizer. Yeah. Something that is very important is when you are using a real power system analysis software. When you are using a real power system analysis software, the software is considering all the information regarding your equipment. For instance, the data that is provided originally from the PM Anderson book, they say that the voltage is 230 kV and the base is 100 MVA. Okay? But what is the problem? That is the base. That is the base of the per unit system. However, we need to define here what is the apparent power of those transformers. What is the reason? Well, the reason is that we don't want to have overloaded conditions at the transformers. If you use 100 MVA as a base, and then you say that the transformer is 100 MVA, well, we will have a problem, because if you look the load flow data, one of those generators is sending 163 MVA, megawatts across the transformer. That means if you install a 100 MVA transformer, you will be destroying, you will be burning that transformer. Okay? Probably you don't see what I'm trying to explain, but here with some numbers probably you will be able to understand my explanation. Here we have the results as published in the PM Anderson book, okay? And if you look over here, 163 megawatts are moving across this transformer. If you install this transformer 2 using 100 MVA, to be honest, that is unrealistic, because this transformer will be destroyed because the power that is produced by this generator is 163. To avoid that situation, I decide in this exercise that the transformers have the nominal value of 250, 200, and 150 MPa. Okay? It's a decision that is also used in other places. Later I will show you that the data provided by PowerFactory for the PM Anderson system is also the same data that we are talking about here. Okay, 250 MVA for transformer 1, 200 MVA for transformer 2, and 150 MVA for transformer 3. Okay, but now what is the situation? The situation is that the table 4.1, you can see here, this is the transformer 1, transformer 2, and transformer 3. transformer 1, 2, and 3, they are expressed in 100 MVA and 230. And because we cannot use 100 MVA transformers, well, we need to transform the impedances or the reactance from 100 MVA into 250. It's very, very simple. You must remember from your classes of power system analysis, there is an equation that allows you convert per unit values in one old base converted or referred to a new base. This equation is extremely simple. What we need to do here is, for instance, transformer number 1. What is the new impedance? We use the old base for voltage, the new base. In this case, for the voltage, there is no problem because the voltage before and later is the same. Yeah, this is, and we divide 250 MVA. This is the S new 250 MVA, and the base that was originally used for the data is 100 MVA. When we put the numbers here in this equation, we got a very interesting result. Okay, using the calculator, 2.5 times 2.5 times the reactance, that is 0.144 per unit, that is equal to 14.4%. Okay? Well, it's extremely simple. What we need to do is run the calculation for the transformer number 2 and run the calculation for the transformer number 3. Okay? Okay. Well, I will open again the question time for per unit values. Oh, I got a very interesting question here. Can I pick up other nominal power for the transformers? To be honest, the answer could be yes. The answer could be you can use another nominal values. However, it's a very complicated decision. In this case, I decide to use those values because those values are defined by other people. I mean, many years ago, people realized that using 100 MVA present an overloading situation on those transformers, and some people say, okay, those are the nominal values for those transformers. Okay. However, I have good news for you. You have an assignment, and for that assignment, you don't need to make any selection about power transformers. For that reason, don't be scared about this step. Okay. Any other question at this moment, please? Okay. If we don't have questions, now is probably the most important time for you, okay? Because now we will start to create the power system inside PowerFactory, okay? Right now I will ask you to open, all of you, your microphone, okay? Please don't make any annoying noise. However, I want that you keep open your microphone, in order that I don't want people feeling behind or falling behind. I will try to do this exercise as slowest as I can, but if you feel that you are delayed or you need more time to accomplish the activity, just feel free to say wait, and I will decrease the speed, or also I will stop, or if needed I will come back. Okay. Okay, now I need confirmation that all of you are with me. Are all of you with me? Please use the thumbs up for confirmation, please. Thank you, thank you, thank you, thank you, thank you, thank you. I think two of you are only one. Okay, good, quite good. I was expecting all of you were sleeping. Okay. First step. The first step is we need to create a new. You can remove the thumbs up, okay, please, in order that we reuse later. Okay. I will use the thumbs up of confirmation that you are alive over there on the other side of the screen. Okay. Okay. First step. The first step is I need to create a new power system. How do I create a new power system? Okay. There are two ways to do this. The most simple way, and sometimes I call this the elegant way to do things, is going to the going to the main bar on the top, select new, and you can see that there is a secondary window over there that say project. Okay, I need that all of you select project. Okay, you must do a left click here, and suddenly a new window appear. Okay. Sorry for annoying you. I hope all of you are with me in the same window. Okay. If you are with me, I need that you understand the following. Okay. Somebody showing me a hand. Mr. Busal. Mr. Busal, are you showing me a hand? What do you need, please? Hello? Well, I think he is sleeping and he put the hand up. Okay, I will keep going. Okay, coming back to my explanation, you must have this window over here. I need that you start to speak PowerFactory. Probably you are confused. What does mean speak PowerFactory? every single window inside PowerFactory here on the top, you can see a title, okay? For instance, in this case, say project, but what I am really interested in is the last 6 letters that you can identify over there. The last 6 letters, I think you can, it's clear for you, okay? I believe you can see that the last 6 letters, they are saying int p, okay? I need that you understand that every single window in PowerFactory has some letters, but I need that you understand this is an internal object. And here is, okay? I need that you care about what these windows are showing to you, because that will give you some extra information and then will make your life easy, okay? Let me come back to my explanation. Now we need a project name. Let's use as project name PM Anderson, PM Anderson, and I will call 9boss system. Sometimes I use version number 1, okay? You don't need to do this, but I will put a 0 at the very beginning of the name, okay? That is because my database is relative big, and I would like that this project will be at the top of my database. PowerFactory use an alphabetic order for the database, and if I use the number 0, it will put the file, the database for this project at the very top, okay? Another thing that you can do when you are creating your project is, for instance, if you want to add some additional information, you can go to here. We call these tabs. Basic data is the basic data that is required to for this object. And here at the very end there is a tab that say description, and I will put here, this is the PowerFactory model of the PM Anderson test system, okay? Sometimes it's a good idea also created. Today is 12/03/2020. Sometimes it's a good idea also to include some information, project version, and also it's good idea to documentate data taken from, and I will put here, this data is coming from PM Anderson book. PM Anderson book is actually a book that is based in 2 authors. One of them is Paul Anderson, and the other one is Fuat. And I am including here the name, power system, control and stability. Okay. The book is the second edition of this book, and it was printed in New York. By IEEE Press, one very serious publisher, in 2003. Okay, and also this system appeared in the famous book, the Pitzauer PhD thesis include the basics of this system, and it was this book published with Professor Pai from University of Urbana-Champaign. Okay, this is Power System Dynamics and Stability. Okay, and this is Prentice Hall. And it was 1988. Okay. Again, it's good idea to put information about what you are doing. What is the data source? What is the status of this project, and so on. Okay. When you complete all the data, you are able to say, okay, then now you can see that a new window appear. Okay, again, I need that you think about PowerFactory. I don't know if you can see the new window. And on the top of this new window, you can see over there okay. In this case, you must understand this is an element, and this one is network. Okay. Why those names are so important? Because if this is an internal object or this is an element, the data that we need to put inside the object could be different, but also the way to access that data can be different. Okay? Another thing that you will realize is that PowerFactory include colors for some icons, and in this case we are using a grid. Sorry. And I believe you can see this is green color. Okay. Please be aware that the elements inside PowerFactory, the objects that they belong to the type that is an element, they are in green color inside PowerFactory. This green color is a code that will allow you to understand better the software. Okay. Okay, let me keep going with my explanation. Now we need to define what is the network of this grid, and I will call this Power Network. What a beautiful name, Power Network. And then you need to put here who is the owner. In this case, the owner is me, and I am including my name here. And then I need that you learn some other stuff here. Okay. Okay. First thing that you need to understand is PowerFactory is talking to you. When PowerFactory is talking to you, you must care about those letters here at the title. For instance, I don't know if you can see, but there is a small asterisk. There is a small symbol that appears. What does mean that small asterisk on the top? That we are making changes and those changes are not updated into the database. Those changes that we are doing right now, they will go into the database when we press this button OK. You will see that when I press that button, this window will disappear, but many actions will happen. Okay? Okay. Second important thing that I need that you understand. We are working right now with an object that is a network element. But this object has some attributes. If you put the cursor here, you can see that the attribute is log name. To be honest, inside PowerFactory, every single object uses the same attribute for the name. All of them are log name. Log name is the name of every single object inside PowerFactory. Here below, you will see nominal frequency. What is the attribute for the nominal frequency? Very simple, FR nominal. FR nominal. In this case, my dear students, you can see over there that by default, the nominal frequency is 50 Hertz. It's very simple. We are in Europe, nominal frequency 50 Hertz. That is the reason that we are using 50 Hertz over there. However, you must understand that the PM Anderson is a 60 Hertz system. For that reason, I must change the nominal frequency, and now the nominal frequency must be 60 Hertz. Okay? At this moment, we are ready for completing this step. Now let me press OK. Okay, now we are in a very important moment because right now you have created your first project inside DIgSILENT PowerFactory. However, this project has no data more than the data that you complete. I mean, nominal frequency, what is the name of this project, okay? And the name of this grid. I believe if all of you follow, there is a big area here in the middle that is the graphical window. And in this graphical window, you can see the tab on the top. And the tab say Power Network, because that is the name of the grid that we provide to PowerFactory. And that name is also the name that is appearing in the project overview, that is the Power Network, okay? Imagine that you would like to rename. You can use basic right button like in Windows. PowerFactory allowed to use the right button like in any other Windows-based software. You can use the right button to go for some additional menus and to do some other stuff. Okay. Okay. At this moment, I will ask: are all of you with me? Please thumbs up if you are with me, please. Okay. Wow, I am really surprised. Extremely pleased and surprised. You stay there. Okay. Let's do the following. Is 10:40. Can we have a break in order that you can have a coffee? And can we come back in 15 minutes? Okay, let's do the following. Let me open let me come back here to PowerFactory. We are back, and we were working with the PM Anderson system, and we create a project. And my students must be extremely happy because they create the first project. To be honest, I don't know if you realize, but PowerFactory it's talking to you, and PowerFactory has been talking to you about this beautiful project that you create. Give me a second, and I will show you something. Give me a second, and I'm sorry. Let me close this. Okay. Give me a second. PowerFactory is closing. Probably my database is so big. Okay. Let me start up. Okay. Every time that you are doing something inside PowerFactory, remember there is a graphic window here on the top, and there is a small output window. Well, it's not small. You can define the size if you wish, or you can use two buttons here at the top. You can maximize the output window, and you can maximize here just the graphic window. And if you would like a place in the middle, well, you can use you can modify this size. What is happening? That is not modifying the size. I did something wrong here. Okay. Come on, what's happening now? This is to maximize. Okay, no, this is not what I want to do. I want to just change the size. Okay, now I did something wrong here. Okay, now it's in the middle. Okay, you can change the size of your output window. Also, you can select what kind of data you want to see. I mean, for instance, if you want to just see the information, you just need to click here and activate and deactivate. Okay, but let me come back to my explanation. There is a big empty area here in the middle, and that is the graphic window. Okay, the first thing that I need that you be familiar with is the freeze mode. What does mean the freeze mode? The freeze mode is the small button that you can find on the top left hand of your graphic window, and if you click or declick, you can see there is a small lock over here. If the lock is closed, you cannot edit or add any network component to your single line diagram. I mean, if this lock is open, you don't have possibility of modifying, editing, or including new objects in this window. But you must notice when you unlock the lock, you can see here on the right hand side the drawing tool. The drawing tool is the area that you can find all the different devices that you can use in your single line diagram. Okay, time for a short explanation. At this moment, you create a project. But what is, in practical terms, a project? Okay, if all of you are with me, I would like that you go to the toolbar, the second line, and you press the button that is Open the Data Manager, okay? If you open the Data Manager, you must have something similar to the windows that I have in front of me or that you can see at my screen. Could you please use thumb ups and confirm that you have this window in front of you, please? Could you give me thumb ups? Yes, Mr. Berger, thank you. Lars, thank you. Who else? Yes, thank you. Thank you. Okay, thank you. Now you can put your thumbs down. Well, no, normal position, please. Don't put thumbs down, okay? Now, I don't know if you realize, but this looks a lot like Explorer in Windows. In blue color, you can see the PM Anderson file that you create, but inside there are some folders. And what I am doing now is opening all the folders, okay? When you create the project, PowerFactory do many things for you. When you create the project, PowerFactory is creating an object, and inside this object there are many other objects, okay? Inside the project there are at least 4 basic folders. I believe you can see that there are at least 4 basic folders. On the top you will find the library. Then below, immediately below, you will find the network model. Third, you will find the study cases. And finally, you will find the settings, okay? Those folders, they have inside another folders, okay? However, at this moment, what I need to do is just a basic introduction of those folders. What is the library? The library is a folder that you can store over there data and objects related with models, with general models, okay? At this moment you probably don't understand what does mean general models, but for instance, a transformer, we use the classic statement model or T model for the transformer. And this transformer has some parameters that define the model. For instance, what is the primary resistance, what is the secondary resistance, what is the magnetizing branch resistance and reactance, and so on. That is the model, okay? That kind of information is stored inside the library. That is different to the network data. I will explain the difference in a few seconds, okay? But the library is mainly a collection of models, okay? Then we have another folder. The name of that folder is the network model, and the network model is the folder that we store all the electrical data, all the connectivity of your power system, okay? That is mainly the reason for the network model. The third folder is the study cases. And one of my students was asking, what is the difference between a project and study cases? Well, the main difference between a project and study cases, a project is the general object, and the study cases is a subset inside the project. The study cases is the place that we can store information coming from the simulation results. At this moment, we don't have so much information inside the study cases, but later when we run the power flow, we will store the numerical results coming from the load flow, from the power flow, into the study cases. That is mainly the reason for study cases. And finally, we have a folder, and this folder is dedicated for settings. Everything that you are doing with your project, there are some settings created by default by PowerFactory. However, if you would like to customize your project, you can go inside that folder and make some changes. For instance, font size, font types, color, symbols, and so on. At this moment, I don't suggest to any one of you to go to settings and make any changes. Probably in the future, with few of my classes, you will be a medium or intermediate user, and probably you will be able to make few changes and customize your project. You can customize single line diagrams, reports for results, graphics, and so on, okay? But at this moment, that is not extremely relevant for you, okay? What is extremely relevant for you is, please be familiar, library, we store the models over there, network model, we store the electrical elements over there, and also the connectivity of the power system. Study cases, we store the results, and that is the most important part for you. I will open for a few seconds questions. If you have any questions about projects, what is, if you have any question related with this short explanation that I did before, okay? If you want to get more information, I highly suggest to read the user manual. There are a few chapters in the section for data handling, and you can get a lot of information over there, okay? Any question at the moment? If you have a question, please put your question in the public chat, and I will try to get my best in order to provide you a proper answer, okay? Well, okay, it's look like we don't have who is okay. How you got the folder filters? It's something that I don't want to explain at this moment. Filters are something that it's not as simple as you think. I prefer that filters will be explained in another session. This session is mainly how to create the system that you need for your assignment at this moment, but probably the next class will be more details and I can go there, okay? I'm sorry, Mr. Berger, at this moment I will not discuss about filters, okay? Sorry. Any other question?